Now, the first thing we've got to see about our functions is how do we graph them? Well, other videos have addressed this as well, so I'm going to go through this relatively quickly. But this should serve as a review for something that you knew 6 weeks or so earlier in the course when we studied quadratic functions. So, let's just say that in solving the simultaneous equations for this function, we get the equation 0.015t squared minus 3t plus 200. Now we understand that process, so we know how that comes about from the data that we obtained. We want to graph this function. We want to sketch a graph. And of course here's going to be the graph, but let's see how we get to that. To graph, we want to find the axis intercept or intercepts, if they exist, and the vertex. That's how we graph a quadratic function. Now there are other things we can do, but that's where we start. And I'll put down here, if any. You always have a vertex, but you might or might not have axis intercepts. As a matter of fact, in the case of this function, it's going to turn out that the function opens upward and the vertex is above the horizontal axis, so that we don't have any zeros. Okay, well, how do we get the Y-intercept? Now, people did extraordinarily well with this, and this is in our MCR class for December 4th, 2017. So, people did real well. I said, oh, how do you find the Y-intercept? And people pretty quickly said, without a lot of prompting, that, well, that occurs when t equals 0. Well, that's easy to calculate then. If t equals 0, we get y equal 200, and that's completely straightforward because both of these terms are going to be 0. Now, the t-intercept occurs when y equals 0, so what's our value of t that makes y 0? Well, you might suspect from what comes out of this that there is no such t, but let's verify that. Here's our equation. Y equals 0 means what? Well, y is this function, so it means that this is equal to 0, and people wrote this down quite promptly, and I was very pleased to see that. Now, at that stage, people got a little fuzzy, and they were even fuzzier in the 163 class last week. To solve this equation, we have to recognize what kind of an equation it is. It's not a linear equation because negative 3t plus 200 equals 0 would be a linear equation. But we got this t squared term here. So this is a polynomial equation. And more specifically, this is a polynomial equal to 0. This is a quadratic polynomial. So this is a quadratic equation, and we can solve it using the quadratic formula. I'm not going to write down the quadratic formula, although I did over here. We just immediately identify A as 0.015, B is negative 3, C is 200, and we write it down. Having written it down, we start by looking at the discriminant, the quantity under the radical, because the nature of the discriminant tells us whether we have to go any further, and it's also going to tell us how many y-intercepts we have. This discriminant turns out to be negative, which means we don't have any real valued solutions because we can't take the square root of a negative. It's undefined. Okay, so our discriminant tells us that there are no real solutions. So we know now that the graph is not going to intercept the y-axis, the t-axis, I'm sorry. We know that there's a point above the t-axis, so we know the whole graph then has to stay above the t-axis. Now, where is the vertex? They memorize a formula for that, but it's an extra formula. Why not just understand the quadratic formula and what it's telling you? The zeros of the quadratic formula are here at these t values, as we should know. And I can express this with two terms, negative b over 2a by the distributive law, plus or minus the square root over 2a, the square root divided by 2a. This means that the zeros are this distance here or this displacement, to the right and left of negative b over 2a. Okay? Because when you add this thing, it's on one side of negative b over 2a. When you subtract, it's on the other side, and that leaves negative b over 2a. Since these two would be equal distances on one side and the other, negative b over 2a is halfway between, and that's because of the symmetry where your vertex is going to be. It's going to be at t value negative b over 2a. Okay, so we say halfway between the zeros is this, and by the symmetry, this is the axis of symmetry. The line t equals negative b over 2a is a vertical line with t coordinate negative b over 2a, and that vertical line is the axis of symmetry. The vertex lies on the axis of symmetry, so the vertex occurs at t equals negative b over 2a. So we can easily figure out what that value of t is. Here, for the only function that we've talked about, b is negative 3, a is 0.015, so negative b over 2a is the negative of negative 3 over 2 times 0.015, which is 100. Now we know that the vertex of this parabola is going to occur where t equals 100. Now at this point we don't know what the y value is going to be, but we know that the t value is 100. So we draw this light dotted line, or it's actually solid in this case. This vertical line is our axis of symmetry, and our parabola is going to be symmetric with respect to this line. What we get on one side of the line, if reflected through the line, gives us the other side of the line. Okay, so our vertex occurs when t is 100. To find the location of the vertex on the graph, we simply have to find the y-coordinate. And how do we find the y-coordinate of the vertex? Again, I got a very good response from the class. Well, you plug in 100 for t. So that means we're going to get y of 100 using function notation, y of 100. And if you calculate that, if you do y of 100, that means t is going to be 100. You're going to get 50. Okay? Now, if I was going to be real consistent, I should have called this y of t, but that's implicit in the context of everything we've been doing. Still, I'll make that little change. Okay, so y of 100 is 50. Replace t with 100, you got to replace t with 100, you get 50. So the vertex is going to occur when t is 100 and y is 50. That's here. We've got this point 200, 0, 200. Now we draw a parabola with a vertex with this point and a vertex down here. And now we've got our y1 of t function, our y of t function. So here's our y of t curve, our y of t graph. Now I also commented that this part of the curve is not in the domain of the function. And why is that? Well, if this was in the domain of the function, remember this is a model of water flowing out of a cylinder by leaking out of a hole. Water is going to flow out. It's not going to flow back in, but that's what this part of the curve would imply. So this part of the curve is not in our domain. It's not relevant, and we don't want to be confused by it, and we don't want to be confused by solutions we might get for t values greater than 100, because no t value greater than 100 is in the domain. Okay? So I make the note here, the domain corresponds to the behavior of water in the bottle, which doesn't refill. That's why I cross out that part of the parabola.